Now let's see the mathematical formulations behind the K-means algorithm. And if you remember, in previous lecture, we have just concluded this by simply using the how to find the centroids, by simply using some, there have some mathematical algorithms. That's theorems are called the Loyal's theorem that we have seen in previous lecture. Now let's try to understand the mathematical formulations behind it. And after the formulate the mathematics, then we come to the Loyal's theorem. So suppose let's take the data sets that we have here, D. Okay. So D, suppose let's take we have n number of data, x1, x2, x3, like that. We have n number of data for this data set. Okay. Now the task that we have here, the main task is, so always it's better if you first write your tasks, and on the basis of the task, if you just formulate these things, always remember this thing. This is the first thing that we have to remember. What is our main task here? So task here that we have to find the centroids. That's the main job. If we find the centroids, then on the basis of the centroids, we can easily find the clusters. So the first thing that we have to find the centroids. And already we have seen here K is our hyperparameter that we have to choose how much cluster we have to interested to make in our class data sets. Suppose let's take the interested that we have interested here is K such kind of centroids, means we have interest to build K such kind of clusters. So the task is here, we have to find the K centroids. The job is we have to find such kind of K centroids. Suppose let's take the centroids for this is C1, C2, C3, like that, CK. Okay, like that. Now, after the second task that we have to do, on the basis of this centroid, we have to find the clusters. So clusters, we have to find the clusters for each centroid. Suppose let's take the cluster for the centroid C1 that we get is 1. For the cluster for the centroid C2 is 2. For the cluster for the centroid C3 is 3. Such kind of cluster. We have to SK. It will be SK. Okay? SK. Now the xj, now the x that we have in our data sets, that belongs to for all xi, also belongs to any of our sk, any, suppose let's say xj, where j is from, where j is, it will be 1 to k, and that thing you have to remember always k is less than equals to n. Okay, where n is equals to number of data sets in our data set, and k is the number of clusters that we are interested to build. Number of clusters that we have interest to find the cluster. That's the thing. And another thing is that for all ij means for the ij will, that's for all ij is I, intersections is j. Intersection is always must be 5, where I and j will I is in 1, 2, 3 up to k. That's the thing. That is the thing we have to always remember. That's the first task that we have. Okay. Now let's see how we will formulate the mathematics. So first that we have to find the centroid, means the centroid, in which basis we are interested to find the centroid. The centroid, that the basis of this we have to find the minimum distances between the each point. So the first is we have to find the distances. Suppose let's take, we have considering any point x. Now considering any point x on our data set, and now we have to find the distances from the H cluster. It means from a centroid. Let's take any centroid C. This is the norm distance that I have taken here. This is the norm distance simply, and we have to find its distance square. Since I'm talking about the Euclidean distance. Just write the picture side by side, then I think it will be better for us, better understanding. Suppose let's take, this is some kind of point that we have in our data set. Suppose let's take, and the centroid for this point is like here. Suppose let's take it like here. Suppose let's take this centroid that we interested, ci. Let's start. So first thing, suppose let's take it's any point x. Suppose let's take it's any point x. First thing that we have to calculate the distance from the edge distance. From the edge point, we have to calculate the distance. From the edge point, to calculate its distance from the centroid, ci. So because of that, we have used this formula, norm of x minus ci whole square. Now, the sum of the distance that we are interested in, the sum of the distance. Second thing, we have to find its sum. What is the summed value here? Okay, summed value means you have to consider the x. We have to consider the x. If this is lie on a single cluster, suppose let's take this is a cluster. Let's take this the cluster. Suppose let's take x si cluster number si, and corresponding the centroid for this cluster is ci. So the x that we have is x is the all the problem, means we are interested to find the distance from all the point of this cluster. So x is belongs to si. This is the sum distance from the cluster to the edge point of this cluster. This formula is talking about this. Now on this cluster, after finding the summed value, we have to find the sum of all the clusters. This is the single cluster. Such kind of there have different kind of clusters. Suppose let's take here another cluster, here have another cluster, here have another cluster, here have another cluster. Such kind of many cluster we have. So this distance, this summed distance for centroid to edge pointer. So this from this cluster we will got some value. From this cluster we got some value. From this cluster as well we have got some value. So after end of the days we have to find the total summed distance from each cluster. I suppose let's take it index I is 1 to k. We have, because we consider here how much cluster we have a k number of clusters. So we have to calculate the distance from each cluster. On this, after calculating this value, we have to find the arc mean. That's things in previous logistic. Just remember logistic regressions, SVM, Lilian regressions, that kind of things already we have used. I think in this lecture, you understand these things, how these things comes. Okay, so arc mean, in which argument we have to find? We have to find this centroid. We have to find the centroid value. What will be the centroid value? We have to interest to find this thing. So now the argument is you have to find the such kind of ck values. C1, C2, C3, like that up to ck. We are interested to find this kind of centroid from these equations, using these equations. Now these equations, now try to understand. I think from these discussions you got how these discussions work actually. Now let's write these things. These things means, just I am talking about this first sum value. These things are called the square distance of the x. These things are called the square distance of x from the centroid ci. Ci means centroid of the cluster is I. That things are talking about these things. This means what? This means the intracluster distance. Just if you just see this thing. This part means this part. These things are the intercluster distance. Intracluster. These things are the intracluster. If these things are the intercluster, these things are the intracluster. Just don't be confused. Intracluster distance. These things are the means I'm talking about this distance, this kind of distance. These are the intra-cluster distance. Okay. So after finding these, we have to minimize these things. We have to minimize this intra-cluster distance is minimized from this algorithm to minimize these things. This intra-cluster distance will be minimized. Okay, that's the thing that we have to, the main job on this lecture. That's what we have to do. Okay. Now, after, this is a simple our objective functions of our optimization problem. Now, what will be the constant of this optimization problem? The constant now will be such that the constant value will be here. All the point will lie on the edge cluster. First constant. Second constant is its I and is j. It must be a null set. It must be the intersection must be null set, means the edge cluster must be a partition to our data set. So they have no common point in edge cluster. Must be, that's the thing. So on this is a constant that we have. These are the constant. Okay. So now the questions that come into our mind: how to solve these equations, how to solve this optimization problem. This is the objective functions, this is the corresponding constant of this objective function, and these total things are actually called the mathematical optimization, mathematical objective functions of this k-means algorithm. Okay, that's the total thing that we have, that is the call actually. Now let's try to understand how to solve this thing, how to solve this problem. Main concept, how to solve this thing. So just rewrite this thing, just the formulation that we have made, just clearly rewrite these things. I think it's really better for us. Mathematical objective function. What is the mathematical objective functions that we already got? And so you have to find the arc mean of, interest to find the centroid, such kind of k centroids, q1 c2 up to ck, and first you have to find its distance in intra-cluster distance, x minus ci a whole square, and its summed value we have to find. Hx must be belongs to the is I of the sum. We have to calculate it, which I must be like on 1 to k. Okay, this is the simple optimization problem, optimization objective function, that's things. Corresponding constant, it will be constant, constant it will be such that constant value hx must be lie on this x belongs to si, and the intersection value between the any two cluster, it will be lie is equals to phi set. I j must be lie on 1 to up to k. That's the thing that we have to maintain, and these functions, these things are actually called the that we got. These things actually called the sum of the square distance from the centroid in the cluster, each cluster. These things are called the sum of the square distance for centroid in the cluster in the cluster si. clusterization. Okay, and these summations are denoted for all cluster. These summation, this summed value, the second summed value means denoted for all clusters. That's the thing that you get for all cluster. These things are for all cluster. That's the thing. But the questions that to solve this optimal problem, objective function means that I think it will better you write this the optimal problem. Mathematical optimal problem. Okay, that's the simple formulations. Now to solve these things, it's very hard. It's totally in general it is impossible to solve things. But there have some hacks. The mathematicians have developed some hacks to solve this problem. Now let's try to understand how to solve. To solve this problem, this is very hard task. To solve it, solve it, solve it is a very hard task. It is a very hard task. In general, it is possible. So to solve this, we have there have some hacks to solve it. So if you are a computer guide students, then you can easily understand. And there have one chapter in computer science, the complexity theory. If you are a computer science student, then you can easily understand there have one chapter in computer science, the complexity theory. Complexity theory. So in the complexity theory, in this theory, there have one problem, NP-hard problem. NP-hard problem. So instead, these things are the like of NP-hard problem, kind of kind of these things, NP-hard kind of problem. Okay, means in general, if you just see this, it's time complexity to solve these algorithms to solve this problem. It's exponentially increased. This time complexity is exponent time complexity for this problem. Complexity is exponential. It has the exponential time complexity. Exponentially increased time complexity. Yeah. So here we have how much points that's in our data sets. In our data sets, we have taken here n number of data points. So the data points here we have taken n data points. For n data points, the time that actually that need is approximately order of to the power n. Actually, it's very hard. Okay, means in MP hard type of problem. So don't be confused about these things. If you are another background student, means if you are a mathematics background students or if you are electronics background student, don't be confused how to solve these things. Now just follow these things through step by step. Okay, I think it will be easy for us. So just be confused how to solve. Now there have some hacks. Now we have discussed this. So CS in CS chapter, the hard problem that we have seen, NP hard problem. This is the hard problem. So by using the simple approximate, there have some chapter also. There are some algorithms also to solve this thing. In the approximation algorithm. We will learn this thing. Approximation. Approximation algorithm. There have some. By simple, actually to get the actual answer for this problem is totally impossible. So to avoid the exponentiality to its time complexity, here we have used these approximations algorithms to find not the proper answer but near about the answer. Means it's near about the correct answer. We will try to find it. Okay. So these are the some hacks they have some use. We will use some peak of the mathematics. Really, they have some There are some hacks behind it and simple mathematics they have behind this approximation algorithm. Using these kind of things, we will try to approximate the solutions of these problems. But not, we will not. It is totally till now. It is not till now. It is totally impossible to find the correct answer. But it's we can using some hacks and mathematics. We can find some approximate solutions of this problem. So to find these problems, we have to we have to use here Loyal's theorem. Previous class also we will discuss Loyal's theorem that we have to use Loyal's theorem. Okay, so it is a very simple and very good also a very good approximation. First thing for this Loyal's theorem is it's very simple algorithm. Very simple algorithm. The second thing is it's the very good approximation. There are various kind of approximation algorithms, but because of its simplicity and it is a very easy to understand because it's very good approximation algorithms, we will use these approximate Loyal's algorithms to approximate the answer for these mathematical problems. Okay, for these mathematical problems of these clusters to find it's the centroid of the clustering k-centroid method. And it's very good. It's a very good approximation theory. Okay. Now in next lecture, we will see how to use this Loyal's theorem to find the centroid of the edge cluster. We will see in the next video. But I think from this lecture we will got some idea how to formulate the mathematical functions by simply using the geometry concept. That's the main motto of this lecture. I think you got some idea how to find. The main thing is this up. So the first thing that we have to find the intra-cluster distance, not the this from this distance to this, from the distance from the edge cluster here to here. This is the inter-cluster distance. But here to formulate the mathematical equations, we have to use the intra-cluster distance. Okay, so we have to first find the intra-cluster distance. Now we have to sum it up for all the points of that cluster, and after finding the summed value, we have to sum it up for all the cluster, not for the single cluster, for all the cluster. Because of that, and now on the summed value, we have to find the minimum value for each cluster. Means we are interested to minimize this summed value for those centroid value that are responsible to minimize this sum. And this is the sample optimizations problem that we have to, and corresponding the constant that we have here, x belongs to Si, and corresponding the intersection value for each cluster, it must be an empty set. That's the thing that we have to remember. This is a simple mathematical formulation, but the main hard task is to solve this problem. It's a very hard task. So it is totally till now it is not totally possible to find its accurate answer of this optimization problem. So instead of using the correct answer, we have using some approximation theory here to solve these problems. So to approximation theory that have in generally engineers are used here to solve this problem, the Loyal's algorithm. That's a very good approximation algorithms, and because of its simplicity, we will use this thing. We will use this to solve this optimization problem. So we'll see these things in next lecture. So till now, stay tuned.